Okay, so when you're trying to fill out the unit circle, there's three different things that we need to address. You have to address the degrees of each angle. You have to address the radians, which are what these dashes are for, and the coordinate points, which actually represent the cosine and the sine of each angle. So let's first just go with degrees. So when I think about degrees, we always start here at the x-axis. Remember, this is a circle, a unit circle with a radius of 1. This is 0 degrees. And then this right here is 30 degrees. This right here is 45, 60, and then 90. Okay, so you're pretty clear that from here to there is 90. You learned that in geometry, and probably earlier. And then half of that is 45. And then right here, what we've got is three 30-degree arcs between 0 and 90. And if you cut 90 into 3 parts, you get 30. So that's a third of 90 is 30, 2/3 is 60, and then 3/3 is 90. Okay? You might also notice that the distance between 60 and 30 is 30, and half of that, 15, that distance gives you the middle term, 45. So you can find the middle ones by adding 45 to 90 or subtracting 45 from 180. Or you can say, well, I know that this one is going to be 30 plus 90, so that's going to be 120. And I know the distance between these is always going to be 15, so add 15 and I get 135. Add 15 and I get 150. Okay? Well, 30 added to that is 180, which makes sense because 180 degrees is half around the circle. Add another 30 and you get to 210. Add 15, 225. Add 15, 240. Or 45 plus 180 is 225. Add 30 and I get to 270. Add 30 and I get to 300. 300 plus 15 is 315. Add 15 and I get 330. And then add another 30 and I get to 360. Okay, so we got 30-degree arcs, and then we've got these 45-degree arcs, or 15 in between the two. Okay, so degrees is not such a big deal. 0 to 360, and then the partitioning of each. Now let's do radians. Okay, so a radian angle measure, this is 0 radians, and a full circle is 2 pi. Okay? What we've learned is that pi is equivalent to 180 degrees. So this right here is pi. Okay? Well, if this is 0 and this is pi, half of that is pi over 2. So half of pi is pi over 2. So if you wanted to count in halves, this is 1/2, this is 2/2. So 1/2, 2/2 of pi. If you think about 2/2, that simplifies down to just pi, right? And then so 1/2, 2/2, 3/2, doesn't simplify, so 3/2. And then all the way around we get to 4/2, and 4/2 is 2 pi. Okay, so that's if you're counting by halves. Now let's count by fourths, because I know that halfway between 0 and half is a fourth. So this right here is 1/4 pi. So what I'm going to do is I'm going to count by fourths. I know that this is 1/4. So from here to there is 1/4. From here to there is 2/4. From here to there is 2/4. And if I were to write 2/4, that simplifies down to pi over 2, which we already have. Yeah. So if I go, counting by fourths, I've got 1/4, 2/4, 3/4, which makes sense. It's 3/4 of pi. 4/4. 4/4 is again pi. 5/4 right here. After 5/4 comes 6/4, and 6/4 simplifies down to 3/2, which we already have. After 6/4 is 7/4 right here. And after 7/4 is 8/4. And 8/4 is again 2 pi. Okay? Now I keep writing these down, these ones that simplify, because I want you to recognize that no matter how you count, like if you start with the fourths, you're going to get these as well as all the others, okay? So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Okay. Now, when you think about these 30-degree arcs right here, this right here, there's 3 between 0 and 90, which means there's 6 between 0 and 180. So there are 6 30-degree arcs between 0 and pi. So if you take pi, which is a whole pi, and then you divide it 6 ways, then the first one is 1/6 of that. So this is 1/6 pi. Okay, so think about cutting it into 6. 1/6, this is going to be 2/6. Okay, but 2/6 simplifies down to 1/3. Okay, so I've got 1/6, 2/6. We skip this one because this is not a 30-degree arc. This is 30-degree arc, another 30 puts me at 60, and another 30 puts me at 90. So 1/6, 2/6, 3/6. 3/6 is again 1/2 pi. 1/6, 2/6, 3/6, 4/6. 4/6 simplifies down to 2/3. And then I've got 5/6, which does not simplify, so I might as well just write that in there, 5 pi over 6. And then I have 6/6, which is again just pi, which we already have. So counting by 6, all the 30s, so 30 degrees, 60 degrees, 90, 120, 150, 180. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Well, after 6/6 comes 7/6. So this is 7/6. After 7/6 comes 8/6. But 8/6 simplifies down to 4/3. After 8/6 comes 9/6. But 9/6 simplifies down to 3/2, which we already have. We have 10/6. 10/6 simplifies down to 5/3, so 5 pi over 3. And then we have 11/6, and 11/6 does not simplify. So you can see on the outside how I have all the 6 to count those 30-degree arcs, okay? I have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, and 12/6 is again 2 pi. Okay? So when you need to count the radians, what you could do is not fill in any, like just start with the 6th or start with the 4th, so it doesn't really matter. If you start with the 4th, you've got 0, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. You should always simplify if you can, okay? And then you count by the 6th. 1/6, 2/6. Now, you already have this filled in, but don't forget that that is a 6th. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6. Okay, so now we need to fill in the coordinate points. Now, if I asked you to, on the x and the y coordinate plane, graph the point 1, 0. Hopefully you would know that the point 1, 0 is over 1 and then up 0. So that would be the coordinate point 1, 0. Well, remember the unit circle is a circle with a radius of unit 1, which means on the coordinate plane, this is the point 1, 0. And if that's the point 1, 0, then that means up here we have the point 0, 1. Over here we have -1, 0. And down here we have 0, -1. Okay? Now what we need to do is find the coordinate points for each of these angles right here. So, I know that this right here is a triangle, well, this angle, this right here, from there to there is 30 degrees, right? So I'm just going to draw myself a little reference triangle. If I go 30 degrees, I know using special right triangles that if the hypotenuse is 1, because we're talking about the unit circle, right? If this is 1, then so is that right there. These are all radii. All the hypotenuses of the triangles are 1. Whatever the hypotenuse is, the short side is across from 30. It is half of that, so that's 1/2 of 1. And then the long side is the square root of 3 over 2. Okay? So when I think about finding the x and the y coordinate of that point right there, well, the x and the y is how far did you go over to the left and how far did you go up, right? Well, we went to the left, square root of 3 over 2, which is the next value. And we went up 1/2. which is the y value. But they're actually more important than just that. If I just say, well, I know that the x is that and the y is that because of 3690, that's fine, but there's also something else special about those numbers. And the fact of the matter is that if I asked you to find the sine of 30 degrees, well, it would be opposite over hypotenuse. And opposite is 1/2 over 1, and 1/2 divided by 1 is just 1/2. So the sine is actually the y value. And if I asked you to find cosine of 30, then it would be adjacent over hypotenuse. Hypotenuse is 1. So even though we're dividing the adjacent over hypotenuse, it's really just the adjacent, square root of 3 over 2. So, and this is what happens every single time. When you have a triangle and the hypotenuse is 1 on the unit circle, sine and cosine are just the opposite and the adjacent. And that is the coordinate point of that point right there on the circle. So, one thing that you might make note of is that on your unit circle, all these coordinate points, the first part is the cosine of the angle, the x is the cosine, and the y is the sine. Okay? So, if someone asks me, hey, what's the cosine of 30? If I'm looking at my unit circle, I'm like, well, the cosine is square root of 3 over 2. And the sine is 1/2. Now, if they ask me, what is the secant? Well, secant is the reciprocal of cosine, so secant would be 2 over the square root of 3, which is 2 root 3 over 3. And if they were like, well, what is the cosecant of 30? Well, cosecant is the reciprocal of sine. Sine is the y value, so it's, instead of 1 over 2, it's 2 over 1, so 2. And I'll show you a few more of those. Okay, so let's do 45, 45, 90, because I want to do this one right here. So I want to find, if I drop that down and draw my triangle, what is that coordinate point? Well, in a 45, 45, 90, in a 45, 45, 90, again, remember we're dealing with the unit circle, so the hypotenuse is 1. Okay, if the hypotenuse is 1, then the side lengths are the square root of 2 over 2. And we get that from saying, you know, if you have a 45, 45, 90, the side lengths are the same. So whatever they are, they're the same, right? So if x squared plus x squared equals 1 using the Pythagorean theorem, then that means 2x squared equals 1. Divide by 2. Take the square root. The square root of 1 is 1. The square root of 2 is the square root of 2. Rationalized, 1 over the square root of 2 is square root of 2 over 2. Okay? So, I've got, well, as far as like what this coordinate point is, which is what this coordinate point is right here, I need the x value and the y value. Well, the x value is square root of 2 over 2. And the y value is square root of 2 over 2. Okay? Now, when I think about this one right here, for this 60 degrees, and I drop it down and make that, this is basically this triangle, but instead of the 30, it's a 60. They just switch. So let me draw that right quick. If we go 60 degrees, drop it to the x. This is the 30. The hypotenuse is still 1. Across from the 30 is the shortest side, that's the 1/2, and across from the 60 is the square root of 3 over 2. Okay? So when I when I need to find the x and the y, I know that the x is the horizontal distance, which is 1/2, and the y is the vertical distance, which is square root of 3 over 2. Okay. Now, as far as filling out the rest of them, this right here, this 30, 60, 90 triangle, is the same triangle as this right here, and the only difference is the fact that instead of going to the right square root of 3 over 2, we went to the left square root of 3 over 2, because these distances are going to be the same as those distances right there. So the y value stays the same, it's up 1/2. But the x value, instead of going to the right square root of 3 over 2, I went to the left, so it's negative square root of 3 over 2. So it is a negative square root of 3 over 2. Okay? And the same goes for this. The y values are the same. It's square root of 2 over 2. But the x value is negative. Just like, I mean, if I asked you to plot the point, negative 3 comma 4, you would go to the left 3 and up 4. Yeah? So, these points are the same as those points, because this is a circle. It's not like, and these are symmetrical, yeah? Those are the same spots. What I have to know, sorry, my light just turned off, is that the only thing difference is that the x's are negative. Okay? So this triangle right here and this triangle right here are the same, only the x value is negative. So negative 1/2 and the positive square root of 3 over 2. Okay? Now when I think about this triangle versus this triangle, well, the only thing different, they both go to the left negative square root of 3 over 2. But instead of going up 1/2, I go down 1/2. So now they're both negative, which is true for every coordinate point in the third quadrant. X is negative and y is negative. Okay? These are the same distances, only the x is negative and the y is negative. My negative keeps running into my square root. Okay, and this is the same as that coordinate point right there. So it's a negative 1/2 and a negative square root of 3 over 2. Okay? And again, it's just a reflection of it. All of these triangles are the same triangles, that's just where they're placed, right? So this is over square root of 3 over 2 and up 1/2. Well, this is over square root of 3 over 2 and down 1/2. So still a positive square root of 3 over 2, but down 1/2. This is over square root of 2 over 2, just like that one, but it's down down square root of 2 over 2. So we'll do square root of 2 over 2 and negative square root of 2 over 2. Okay? And then this one is over 1/2, just like this one is over 1/2. But instead of going up square root of 3 over 2, we're going down square root of 3 over 2. So we're talking about x values versus y values in what coordinate plane. And if you're in this quadrant, in the fourth quadrant, x's are positive, y's are negative. X's and y's are positive in the first, x's are negative, y's are positive in the second, x's and y's are negative in the third. Okay? So far what you've done is you've completed the unit circle. How did we do it? Well, the angles, we went by 30s and we went by 15s to get to the 45s. 90, we knew that was 180, and then just keep counting the 30s and 15s or the 30s and the 45s. Okay? Radians, 0, you have to remember that that's pi. And if you can remember that that's 0 and that's pi, then the rest is just filling it out. So this is half of that. This is a fourth of that. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And as far as the 30-degree arcs, 30, 30, 30. Count by 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6. And then it's a matter of filling out these coordinate points. We have to remember that this is a circle with a radius of 1 on the coordinate plane. So over 1, up 0, 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then if you know your special right triangles, then you can fill out this first quadrant, and then you can just reflect it everywhere else. Okay? If this is a 30-degree arc, then whatever this is, if the hypotenuse is 1, across from the 30 is 1/2, and across from the 60 is square root of 3 over 2. Okay? Now, there's a pattern, though, to it, if you think about this. These are all divided by 2. All these fractional coordinate points are divided by 2. So that's something that's in common in all of them. And then you might notice that there's a pattern to the numbers as you go. If you look at this as 0, and the square root of 1 is 1, so we'll do 0, square root of 1, square root of 2, square root of 3, or 0, 1, 2, 3, and just remember those are in square roots. X is in the 0, so 0, 1, 2, 3, right? But as long as you've got one point, you know that this one is just the flip of that one, and that this one is the square root of 2 over 2, those in the middle. 1, 2, 3, 0, 1, 2, 3. 0 is in the x, 0, 1, 2, 3, 0, 1, 2, 3. And you can even count 1 as 4 if you do the square root over 2, because the square root of 4 over 2 is just 1. Okay? 0, 1, 2, 3, 0's in the x, so 1, 2, 3. 0's in the x, so 1, 2, 3. 0's in the y, so 1, 2, 3. But anyway, so that's basically how to fill it out. There's a couple other things that you should keep in mind as far as like finding angle values. Like if I ask you to then say, or to find. So say I said, or I asked you, what is the cosine of 7 pi over 6? Okay. If they ask me what's the cosine of 7 pi over 6, so I'm going to find 7 pi over 6, and it's right there. And I know that cosine is the x value, so it is negative square root of 3 over 2. Okay? If someone asked me what is the cosecant of 11 pi over 6, well, then I look for 11 pi over 6, and it's right there. Cosecant is the reciprocal of sine. Sine is the y value, right? Remember, we have cosine is the x, sine is the y. So when they ask me to find cosecant of 11 pi over 6, I'm going to go to 11 pi over 6. I'm going to figure out which one is sine. It's this one, and I'm going to flip it. And so it's negative 2 over 1, which is negative 2. If someone asks me to find, let's say, the tangent of, let's do the tangent of 120 degrees. Okay? If they ask me to find the tangent of 120 degrees, then I'm going to go to 120 degrees, which is right there. And I notice that tangent is, well, I know that tangent is, well, what do we know that tangent is? We know that tangent is opposite over adjacent in a triangle, right? So if you think about tangent being opposite over adjacent, yeah? Well, think about this right here. Tangent of 30 would be opposite, which is 1/2, over adjacent, which is square root of 3 over 2. But we just said that 1/2 is the sine, and square root of 3 is the square root of 3 over 2 is the cosine. So in actuality, what I end up kind of equating is the fact that tangent is, by being opposite over adjacent, we're kind of saying it's sine over cosine. And I know that we have that hypotenuse thing, so think about it like this. If you think of sine as opposite over hypotenuse, and you think of cosine as adjacent over hypotenuse, and we think about dividing the two, right? Sine divided by cosine is equivalent to saying opposite over hypotenuse divided by adjacent over hypotenuse. And when you flip, or when you divide a fraction by another fraction, you can flip and multiply by h over a, and the h's cancel out, leaving you with opposite over adjacent, which is what tangent is, meaning tangent is sine over cosine. And remember, we just said that cosine is the x value and sine is the y value, so that means tangent on the unit circle is the y value divided by the x value. So let's go back to tangent of 120. Tangent of 120 is right here. Tangent is the y value divided by the x value, so that is the square root of 3 over 2 divided by the negative 1/2. When you flip and multiply, the 2's will cancel out, so it's square root of 3 over negative 1, which is a negative square root of 3. Okay? Let's find another one. If I ask you to find the secant of, let's go with negative 5 pi over 4. Okay? Well, as far as like negative angles go, let's talk negatives for a second. If I asked you to find 30, you would say, oh, it's right there. And if I asked you to find negative 30, you're like, well, it's right there. Okay? So if I asked you to find negative pi over 3, well, pi over 3 is right there. Negative pi over 3 is right there. If I asked you to find 120, well, it's right there, so negative 120 is right there. So it seems to me that the negative angle is just the reflection across the x-axis. So if I asked you to find negative 5 pi over 4, well, to get to 5 pi over 4, I have to go a full half circle and then another quarter. So going backwards, if I go a full half circle and another quarter, I end up at 3 pi over 4, which is just the reflection across the x-axis. So negative 5 pi over 4 is equivalent to 3 pi over 4. And so if I want secant of that, well, secant is the reciprocal of cosine. So cosine is the negative square root of 2 over 2. So it's 1 over the negative square root of 2 over 2, or flip that fraction. negative 2 over the square root of 2. And then if you rationalize, you multiply by the square root of 2 on top and bottom, you end up with negative 2 square roots of 2 over 2. The 2's cancel out, and you're just left with a negative square root of 2. That being said, square root of 2 over 2 comes from 1 over the square root of 2. So I actually when I have to flip this, I just think, oh, well, that was 1 over square root of 2, so when I find the reciprocal, it's just square root of 2 over 1. Okay? Let's do one more. If I ask you to find, let's say, cotangent of negative 300 degrees. Cotangent of negative 300 degrees. So if here's 300, so that means negative 300 is up here at 60. Okay? If tangent is sine over cosine, which is y over x, then that means cotangent is x over y. So it's the x value, 1/2, divided by the y value, square root of 3 over 2. The 2's will cancel out. 1 over the square root of 3 is square root of 3 over 3. Okay? I hope this helped, but as far as filling it out, there's a lot of pattern work, and as far as finding the sine and cosines and tangents, it's really just doing a lot of memorizing, making sure that you know that this is cosine, that's sine, and making sure you know how to deal with the numbers and the fractions and the square roots. Okay?